All right, we're back. This is going to be page 24 of math analysis. We are in the middle of notes 3, I guess. And I'm on this page still because we need something from here, right? So we have decided that based on using this particular point, but also we've decided that in general this should be true. It shouldn't really matter what point we pick. It looks like on the unit circle, the sine of the angle that you're dealing with looks like it's the y-coordinate of the ordered pair. The cosine looks like it's the x-coordinate of the ordered pair. That's what we've decided. We think it shouldn't matter what point you use. We think that cosine should be x, sine should be y. So what we want to do here is we want to kind of like formally write that down. So using these are called the unit circle definitions of the trig ratios, of the trig functions. So let's see if we can write these. So it's really annoying. Like everything is like sine, cosine, tangent, sine this, cosine that. Like you always think sine first, but really it should have been cosine that went first. That would have made your life easier, like in the long run. But it didn't work out that way. So we are thinking that so theta is the angle through. So the angle in standard position through the ordered pair x comma y on the unit circle. So theta is the angle through xy, the angle in standard position, through the point xy on the unit circle. We think that sine of theta should be the y-coordinate, cosine should be the x-coordinate, and then tangent, because of the way it works, you know, we have, here's your y, here's your x, and this is theta. Tangent should be opposite over adjacent. It should be y over x. Now, there's an important little thing here because, hold on, I lost, oh my gosh, what is happening? I lost my ability to write. Let's see. What do I need to do? There's like a way out of this. Hold on. Hold on, everybody. Okay, let me just quit. Gotta quit everything. Quit. Get, and then I'm gonna bounce back in. And then let's see. We might have saved that. We might not have. Let's see. I gotta get down. Here we go. Okay, we are on page 23. We're still going. No, we're on page 24. What are we on? We are on page 24. Okay, so the thing we have to look out for, we're saying tangent is the y-coordinate over the x-coordinate, but you can't have x be 0. Like there's no way that x could be 0 because you can't divide by 0. So that's interesting because what angles on the unit circle correspond to x equals 0? If x is 0, you're on the y-axis. That's pi over 2, 3 pi over 2. It looks like tangent of those values won't exist. It'll be undefined. So then we actually are going to run into that problem everywhere. So for cosecant, y can't be equal to 0. So when is y equal to 0? If y is 0, you're on the x-axis. What angles does that correspond to? 0 and pi. Cosecant of 0 and pi won't exist. And this is just a thing that you will always have to deal with. Here, x can't be 0, so it's the same as tangent, right? So that's pi over 2 and 3 pi over 2. Not going to exist for secant. And then cotangent is x over y, provided that y is not 0. So cotangent and cosecant are going to be similar. So we have to be really careful. You can't divide by 0, like ever. But these are our definitions. These are our unit circle definitions. So we have our right triangle definition. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? Those are our right triangle definitions. So put those away for a second. Now you have your unit circle definitions. Cosine is x, sine is y. So the way that I always think about it is we have x comma y. We have cosine of theta, sine of theta. And they are both in alphabetical order, which I think is the best, easiest way to remember, right? So they're in alphabetical order. X comes before y, cosine comes before sine because c comes before s. X goes with cosine and y goes with sine. So this is immediately something you need to memorize. Like you just have to know that. Now, another really interesting thing, I think, is that over here, if I'm trying to keep track of the color that I used here, so this was X, and then this color is Y. If you look at tangent for a second, tangent is Y divided by X. But what did we just say that Y and X were? Y is equal to sine. X is equal to cosine. It looks like tangent is actually sine divided by cosine. That's going to be a thing. You're going to use that a lot. So it does work out to being a fact that tangent of theta is sine of theta divided by cosine of theta, which is often how I'm calculating them when I'm actually looking at a triangle. I'm actually just dividing the sine and the cosine. If you do all the work to find sine and cosine, you might as well use them like as often as you can. All right, let's see. Using your definitions from above, let's move into the second quadrant. Use the additive inverse of the x-coordinate used the first time. So I think the first time we used 3/5. Yeah, we used 3/5. The additive inverse of that is the number you add to it to get 0, negative 3/5. So we want to move into the second quadrant. So what I'm going to do is see if I can't like just draw something here. And then I'm going to need some axes. It's like it's all fun and games until you try to put the axes in, and then it looks terrible. And then I need a triangle here. And then there's going to be a right angle. So the right angle is always at the x-axis, always. Now the angle theta that we're interested in, that we're finding the sine and the cosine of, is actually this angle. It's always the angle formed with the positive x-axis, always. You always draw your altitude to the closest part of the x-axis. The right angle is always on the x-axis. The angle you're interested in always goes from the positive x, and then you just go counterclockwise until you hit the terminal side. That's what you're always going to do. So this ordered pair is going to be negative 3/5, 4/5. And now we want to use our definitions here. So I'm going to write down the functions. So sine of theta, cosine of theta, tangent of theta. And then before I do anything, I like to write down the reciprocals. So cosecant of theta, secant of theta, and cotan of theta. Okay, so we said that x is cosine. So you should really, I always like in my mind really start with that. X is cosine, so cosine of theta is negative 3/5, which is interesting because that's negative. That has never happened to you in a right triangle before. There are no negative ratios that you can get out of a triangle. But now we've moved on to circular definitions. These are the unit circle definitions. Sometimes these can be negative. And this is like a brand new idea. And then for tangent, I can just do sine divided by cosine, which I'm going to do, right? And the 5s in the denominators just cancel because they're both over 5. And then here, I'll get 5/4, I'll get negative 5/3, and I'll get negative 3/4. Okay, pretty good so far. What I'm going to do is I'm actually going to stop this video here because I'm not going to get through the whole page in one video. It's kind of like roughly halfway there. So what I'm going to do, stop here, come back in the next one, finish this page. Hope to see you there.